Welcome to solverfy.
This problem, we have two vectors that each have magnitudes of 3 meters, and the direction of one of the vectors is going to be 30 degrees. We want to graphically find A plus B A minus B B minus A, and finally A minus 2B. Starting off, we have the vector B looks something like this. It is vertical. And then we have A, which looks something like this, which is 30 degrees up from the horizontal. So starting off with A plus B, the way that we kind of visualize it is by taking one vector and then adding the tail of the second vector to the arrow of the first one. So this is going to be A, this is going to be B, right? Whoop. So then this vector here that connects them is going to be A plus B, right? So that's what it's going to look like. But we want to do some calculations with it because it asks for some angles, it asks for some magnitudes. So let's first determine the components of each of these vectors. Starting off, B is pretty simple because it is completely in the vertical direction. So it's just going to be 3 meters in the y hat direction. You might use j hat, doesn't matter, just means in the vertical direction. For vector A, we have that it's 3 meters times the cosine of that 30 degrees. So it's the cosine of the angle made with the horizontal, and that's the x direction, plus 3 meters times the sine of 30 degrees in the y direction. If we plug this into our calculator, we get that vector A is going to be 2.6 in the x direction plus 1.5 in the y direction. So to determine A plus B, what we want to do is add each component with each component. So we want to add the y's with the y's and the x's with the x's. So A is the only one with an x component, so that makes my life a little bit easier. So I have 2.6 x hat plus, and now I add these y components together. So that's going to be 3 plus 1.5 y hat. Putting that together, that's going to be 2.6 x hat plus 4.5 y hat. All right. So now that we have the components, we can find the magnitude and direction of this vector A plus B. So the magnitude of A plus B really just comes from the Pythagorean theorem. We take 2.6 squared plus 4.5 squared. And from that, we get a magnitude of about 5.2 meters. Now we want to figure out what the angle is. So theta A plus B is going to be the arctangent of the y component, 4.5 over 2.6. And that'll be about 60 degrees. So if we kind of take a graph of A plus B, these are my axes. A plus B is going to look something like this, where this angle here is 60 degrees, and the length of this vector is 5.2 meters. Awesome. Now I'm going to go ahead and erase some of this so we can move on to part B. Okay, part B, we want to find what A minus B is. So one of the ways that we can do that is graphically. We can draw A, and then we put the tail of B onto the head of A, but we flip it. So instead of pointing up, it's going to point down. So it'll look a little something like that. Right, so this is A, this is B, and our resulting vector is going to be this guy, A minus B. All right, so from just drawing this, we can kind of expect that it's going to have a negative angle with the x-axis, and it's probably not going to have that big of a magnitude. But let's go ahead and calculate this. So A minus B, again, we're going to combine components. 2.6 x hat plus 1.5 minus 3 y hat. So putting that together, we have that the vector A minus B in component form is going to be 2.6 x hat minus 1.5 y hat. Now we are going to find the magnitude and direction in the same way. So the magnitude of A minus B is just the square root of 2.6 squared plus negative 1.5 squared. Do keep in mind that when you square a negative, the negative sign goes away. And plugging that in, we get a value of about 3.0 meters. To find the angle, we go through the same procedure, inverse tangent of y, the y component over the x component. So that's negative 1.5 divided by 2.6. And that will give us an angle of negative 30 degrees. So our predictions kind of came true. A minus B is a little bit of a shorter vector, and it also has a negative angle, so it's below the x-axis. So I'm again going to erase to make room for part C. So part C, we want B minus A. So let's first take a look at that graphically. So we're first going to draw our vector B, right? And then we're going to flip the direction of vector A and attach it to the head of vector B. So vector A goes this way, vector negative A will go that way. So that means our resulting vector is going to look something like that. So this tells me that our vector is going to have an angle between 90 degrees and 180 degrees. That would put it in the second quadrant. And also it is going to be kind of small, just like the previous one. So let's go ahead and do these calculations and see if we're right here. So B minus A, again, component with component. So we're going to have negative 2.6 x hat plus 3 minus 1.5 y hat. So that will give us negative 2.6 x hat plus 1.5 y hat. So almost the same vector as A minus B, but we flipped the signs. All right, so to find the magnitude, we do our usual Pythagorean theorem thing. Right? Plugging that in, we get 3.0 meters again, which is pretty cool. And then for our angle, we're going to do the inverse tangent of 1.5 over negative 2.6. So you do want to be kind of careful with the tangent function because calculators have a tendency to only recognize angles between negative 90 degrees and positive 90 degrees. However, by drawing this vector, I know that it's going to be between 90 degrees and 180 degrees, right? So if you get negative 30, again, what you want to do is you want to add 180 to that in order to make sure that it's in the correct quadrant, and you'll get 150 degrees. All right. Now we're going to move on to part D. So for part D, we have A minus 2b. Now when we multiply by a constant, all that does is doubles the magnitude of that vector. It doesn't change the direction of it. So if we were to do this graphically, it's going to be pretty similar to what we did for A minus B, where we start with A like this, and then minus 2b. We're going to take this B and we're going to flip its direction. So instead of pointing up, it's going to be pointing down, and we're going to double its length. So it's going to look something like this. And then our resulting vector is going to be this guy. So we can expect a larger magnitude than A minus B, and we can also expect a little bit of a deeper angle. So let's go ahead and work this out. So A minus 2B, again, we have 2.6 x hat because A is the only vector with an x coordinate, plus, now I'm going to take square brackets. I'm going to take 1.5, so that's from A, and I'm going to subtract 2 times B, so minus 2 times 3 in the y direction, right? So we have 1.5 minus 6. That will give me 2.6 x hat minus 4.5 y hat. Now let's find the magnitude and direction the same way we have been. So A minus 2b, magnitude, is going to be the square root of 2.6 squared plus negative 4.5 squared. You might notice that this looks a whole lot like a plus b, except we have a negative sign in front of our y component. So let's see how that affects things. When we plug this in, we get 5.2 meters. So we have the same magnitude. And now for our angle theta, we're going to take the inverse tangent of negative 4.5 over 2.6. And that gives us negative 60 degrees. So kind of the same angle, just with a negative sign in front because we're dipping below the x-axis instead of above the x-axis. Okay,